The Shell Open Hole Continuous Casing System, or SOCCS for short, is an innovative method for well construction. SOCCS uses the principle of turning an endless pipe inside out to create a double-walled, monodiameter casing which can be of unlimited length. So how does this work in practice? Imagine that at some depth below the surface, a hole is being drilled, with a pilot bit and under reamer. With SOCCS, the hole is continuously cased, directly behind the bit, from surface to final well depth. The double-walled casing is created by pushing the inner pipe downwards from the surface and then folding it inside out at the bending zone. The outer pipe, which is extended at the bending zone, is effectively stationary with respect to the formation. The outer pipe is hung off at the surface in a simple wellhead. To reduce the footprint and to facilitate construction of an endless inner pipe, the trajectory starts off near horizontal. Of course, turning the pipe inside out and overcoming friction between the inner pipe and outer pipe requires some force to be applied, and this is provided by the pipe tractor. The inner pipe itself is actually created on site in a pipe mill. The process involves rolling an endless strip into a pipe and then seam welding it. Using this continuous method of creating the inner pipe eliminates the need for connections. A horizontal drill rig feeds the drill pipe into the inner pipe. This rig has all the normal functionalities you would expect. The flat strip of material that is formed into the inner pipe in the pipe mill is delivered on a coil. Once all the strip from a coil has been used, a new coil is placed and the end of the previous coil is welded to the start of the next coil. So what are the advantages of using SOCCS when compared to conventional drilling techniques? Well, there are several. First of all, the overall construction time for the well is reduced, because changing out the bit is the only time when round trips are needed. Running casing and providing zonal isolation is done simultaneously with the drilling. Second, the volume-related costs are reduced, because fewer cuttings are produced, and less cement and drilling fluid is needed. Finally, open hole-related problems are reduced, because the casing shoe is always just a short distance behind the bit. But that's not all. The coils of strip material that are used to form the pipe are readily available from other industries and are relatively inexpensive. Only a few coils are needed for a complete well, compared to a pipe yard full of casing that would currently be needed for conventional drilling. Patch drilling is possible simply by moving the guide of the inner pipe to the next wellhead. The rig and pipe mill can stay in place. The compact horizontal setup is smaller in footprint and less visible than a conventional rig. This can be a significant enabler when proposing drilling in urban or environmentally sensitive areas. The concept of SOCCS has already been proven by drilling a number of test wells in the north of the Netherlands. In this case, the pipe-forming line and drill rig are located inside the building. Once it has been formed in the pipe mill, pipe is guided out of the building and into a conductor pipe. The conductor pipes are set up with an inclination of 80 degrees from vertical. In this prototype machine, the equipment for secondary well control is mainly situated in the outside area between the building and the conductor. Inside the building, the pipe forming line starts with the coiled strip material. This material is supplied with tight tolerances on the wall thickness and material properties. This stringent specification results in a casing that has very predictable pressure integrity. The pipe mill in this prototype setup is creating a casing with a 4-inch inner diameter. For the next generation of machine, the target size could be a 7-inch inner diameter. Inside the pipe mill, a number of rolling stages form the strip into a pipe. Then, in the welding cabinet, the edges are welded together to form a continuous seam. Operators can closely monitor the combined process of drilling and casing. Particular attention is paid to the process parameters of the welding and to post-welding quality control. A careful watch is also kept on the forces required by the pipe tractor and the distance between the moving casing shoe and the bit. Behind the pipe tractor, a start is made with the process of turning the pipes inside out. This start is then brought to the wellhead and hang off. A horizontal rig is used to drill ahead of the casing. Normally, a rig like this is used for constructing pipelines in urban areas or under rivers. Sensors are installed to monitor pit levels and return flow, among other things. The drilling fluid returns from the well are collected in a pit inside the building. From here, the returns are pumped to the shakers. All the fluid handling equipment is located outside, including the shakers, mud pits, and pumps. The test well in October 2015 set a number of records, including a well depth of 433 metres TVD. A key enabler for the record depth that was attained was the isolation of critical water interfaces. The team proved the concept and therefore demonstrated that a significant reduction in well construction costs is feasible.